Alright guys, so we are about to work through problem 1.4 of Griffiths quantum mechanics, and we're going to be in this video going through part A of this problem where we're going to normalize our wave function. Okay, so in order to do this, we know that psi, specifically the absolute value of psi squared, this integral has to equal 1 because psi squared is a probability density function, and when you take the integral of a probability density function from minus infinity to infinity, it has to equal 1 because probability cannot be less than a 1 or greater than 1. Okay, so let's go ahead and do this. So first gotta start by looking at what psi is. So psi is going to be equal to a times x divided by a times b minus x divided by b minus lowercase a, and then 0 everywhere else. Okay, and let's set up where this is true. So that psi equals this top function when x is between 0 and lowercase a. Psi equals this middle function when x is between a and lowercase b, and then psi is 0 everywhere else. Okay, and so whenever we have a piecewise function like this, or a psi that is piecewise, that means we're going to have to break our integral up into the different regions. Okay, so let's think about it. We have a region, all the x's before 0, so we have the integral from minus infinity to 0 of psi squared dx. We have to add that to the region where x goes from 0 to a, so integral plus from 0 to a of psi squared dx, plus this middle region from a to b, so integral from a to b of psi squared dx. And finally, this last region where everything is 0, so everything from b to infinity of psi squared dx. Okay. So we know this all has to equal 1. But with this being a piecewise function, we can automatically eliminate the regions where psi is equal to 0, because the integral of 0 is just going to give us 0, so we can eliminate this integral and then this integral. Okay, so now the integral from 0 to a of psi squared, well, psi squared, we'll just square this top function because that's what psi is between 0 and a, is going to be a squared times x squared divided by a squared dx. And then between a to b, our psi is just going to be this middle function. So we'll write from a to b of a squared times b minus x squared divided by b minus lowercase a squared dx. And we know this all has to equal 1. So we're getting there. So we get two integrals now. One of them pretty straightforward to calculate, so we'll do that. So this first integral right here, you can pull our a squared out front, and actually we're going to pull this divided by lowercase a squared as well out, and then evaluate the integral of x squared from 0 to a. That's going to give us 1 divided by 3 of x cubed from 0 to a, and we'll work on that as we keep going down. But this next integral over here, a little bit harder, not that much harder though, so we're just going to do a u substitution to clean this thing up. So we'll do u is equal to b minus x, and then that means our du is equal to minus dx, or as I like to write this means negative du will replace my positive dx. Okay, and so we'll have a minus from replacing x with du, And then the integral, also we'll bring a capital A squared divided by b minus a out front. It's going to be squared. All right, so this bottom limit of integration, when we plug this into u, we get b minus a down at the bottom, b minus a. And up at the top, when we plug b in, we just get 0. And then we'll have u squared du is equal to 1. Now this first integral, when we plug a in, we get a cubed, and then when we plug 0 in, we get 0. So this right here is just going to evaluate to a squared divided by a lowercase a squared. All of this times 1 divided by 3 times lowercase a cubed. And we obviously see this a squared and this a cubed will cancel out. And this will give us a times lowercase a divided by 3. Now let's evaluate this integral over here. So we have a minus out front, so it'll be minus capital A squared divided by, and this is kind of hard to see, but it's going to be parentheses lowercase b, lowercase a, all that squared. And then over here we'll have 1 divided by 3, u cubed from b to 0. And like always, this has to equal 1. Okay, so let's scroll down, give ourselves some more room. Okay, so we'll just rewrite this just for a little bit more clarity. So capital A times lowercase a divided by 3 minus, and this is a capital A squared, minus capital A squared divided by b minus lowercase a squared. All this is going to be multiplying 1 divided by 3, and when we plug a 0 in, we get 0, and then when we plug a b in, we're going to get a minus b cubed, so we'll get negative b cubed as this first term. Sorry, this is b minus a. Wow. Oopsie. Let's erase this. So if we scroll back up here, we see our lower limit of integration is b minus a. So this lower limit should be b minus a. So that's my bad. I'll leave it in red to mark my mistake so it's easy to see. So instead of just being a b cubed, it'll be b minus a cubed. Okay. And now we'll have a lot of cancellations happening. So these two negatives are going to cancel out to be a positive, and also I can factor an a squared out. So let's do that. So we'll have a squared all the way over here, and we'll have a lowercase a divided by 3 plus, because the negatives canceled, 1 divided by b minus lowercase a squared times 1 divided by 3 times b minus a cubed. And so we see this factor of b minus lowercase a squared is going to cancel out with 2 of the factors of b minus a up in the top. Almost done. This equals a squared times lowercase a divided by 3 plus 1 divided by 3 times b minus lowercase a. And we see our a lowercase a's will actually cancel out, and we'll get capital A squared times b divided by 3 has to equal 1. And from here, we can solve for a. So where did my pen go? Okay, it's right there. A squared is going to equal to, oh, it's not a squared, let's do a. It's going to equal the square root of b. Wow, having a brain fart over here, or a mini stroke, who knows. This is going to equal to 3 divided by b. And this is our final answer. So this is the final answer for part A of 1.4.